Welcome. This is the lecture video for the Activity 9 review. I guess it's not a lecture video, but it's just a video of me explaining all the problems in the Activity 9 review. Okay, I've already gone ahead and worked out the review, so I'm just going to try to make this video a little bit shorter. I'm just going to explain my solutions that I have right here. So the first section is on Lesson 9.1, which is reflections. So I recommend memorizing these two rules, okay? These are for the reflections over these diagonal lines, so let's write that. So remember, when we're doing reflections over either a horizontal or vertical line, all we need to do is count. But for diagonal lines, it's a little bit harder to count, so I recommend using the formulas or the rules. So the rule for the line y equals x, which is the diagonal line straight through the center of the from bottom left corner to top right corner. The rule is that xy, the new points would be y, x. So all you do is switch the points around. And then for y equals negative x, which is the diagonal line from top left corner to bottom right corner, is xy goes to negative y, negative x. So you swap the coordinates around and you make them take the opposite sign of both. Okay? Alright. So let's look. Let's look at number 1. P1 says we have this triangle FGH. Okay, it is plotted in green, the original. For all these here, the original will be plotted in green, and the orange will be plotted. The image will be plotted in orange. Okay, so we reflect over the y-axis. This is the blue line that I've drawn right here. Okay, it is a vertical line. All we do is count. So FGH is right here. Okay, and then G is 1 away from the x-axis, from the y-axis, excuse me. So we go 1 away for G prime, and then the same for F and F prime. So F is 1, 2, 3, 4, 5, 6, 7. So then we go 7 to the right. 1, 2, 3, 4, 5, 6, 7 to get F prime. H is 1, 2, 3, 4, 5. Then H prime, 1, 2, 3, 4, 5 as well. Okay, that is how we get H prime. And then I plotted my coordinates based on what they were. So F was 7, negative 2. G was 1, negative 4. And then H was 5, negative 5. And with that, we have that. So that is for the y-axis, guys. Y-axis. Okay. P2. We have this trapezoid QRST plotted right here as follows. Points are correct. But this time we're reflecting over the line y equals x. And remember, this is the diagonal line that goes from top right corner to bottom left corner. Has slope of 1 and has y-intercept 0. So that's how it's plotted. We're reflecting over that line. I used the rule for this one, which says that xy goes to yx, excuse me. You just flip the coordinates around. So if q is 4, negative 1, q prime is negative 1, 4. R is 6, negative 1, so r prime is negative 1, 6. S is 8, negative 6, so s prime is negative 6, 8. And then t is 2, negative 6, so t prime is negative 6, 2. Okay, so we plot those, negative 1, 4, and then we get r prime is negative 1, 6, s prime is negative 6, 8, and t prime is negative 6, 2. And thus we have our reflection around the line y equals x. P3. This one we have the square LMNO reflecting over the line y equals 2. Okay. So y equals 2 is a horizontal line crossing through the y-axis at 2. So we just count to find the new points. Okay. O is 1 away, so O prime is 1 away. Okay. L is 1, 2, 3, 4 away, so L prime is also 1, 2, 3, 4 away. And then M is 1, 2, 3, 4, 5, 6, so M prime 1, 2, 3, 4, 5, 6 away as well. And then n prime is 1, 2, 3 away. So n prime is 1, 2, 3 away. Okay. And that's how we find our answer here. Okay. Moving on. P4, we have a rhombus ABCD reflecting over the x-axis. Okay. So we just count again. Should be orange, not purple, but oh. Okay. So change that color real quick. All right. Over the x-axis, A is 1, 2 away. So A prime is also, excuse me. A prime is also 1, 2 away. D prime is 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. B prime is 1, 2, 3. So this is 1, 2, 3. And then C prime is 1, 2, 3, 4, 5, 6, 7 away from the x-axis. So this is 1, 2, 3, 4, 5, 6, 7. And we've got our coordinates as follows right there. Okay, awesome. Alright, parallelogram STUV is with vertices, those right there, is reflecting over the line y equals negative x. Which is our blue line right here. And remember we said it's the diagonal, it goes from the top left corner to the bottom right corner. Okay, so what we do is flip our coordinates. If s is negative 3, 4, s prime is negative 4, 3. So we flip them and make them, not just flip them, we flip them and make them the opposite sign. If t is negative 1, 7, t prime is negative 7, 1. If u is 5, 7, u prime is negative 7, negative 5. If v is 3, 4, then v prime is negative 4, negative 3. And we plot them as like that, okay? So negative 4, 3, negative 7, 1, negative 7, negative 5, and negative 4, negative 3. P6, we are doing triangle XYZ with these with the vertices as follows. We're going over the line x equals negative 4, which is a vertical line, which intersects the x-axis at negative 4. Okay, so we just count 1, 2, so then 1, 2. 1, 2, 3, 4. So 1, 2, 3, 4, and 1 and 1. Okay. That's it for reflections. Next is lesson 9.2, which is translations. With these, you're given the formula, so no formula to remember. And these formulas or this rule, like example for this one right here, is going to tell us how much to go left and how much to go right. I mean, how much to go left or right and how much to go up and down. If it's for, let's see, for x, it's minus. If it's plus, we go right. If it's minus, we go left. And then for y, if it's plus, we go up. If it's minus, we go down. So this rectangle DEFG, this is telling us that we will go 11 left, because it's minus, and 4 up. Okay, so to get our coordinates, we did 6 minus 11. So then let's just do it by counting first. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 4 up. So we did 1, 2, 3, 4. Okay. For E, same thing. 11 to the left, 4 up. Okay, and then we got our coordinates by either looking at them or you can plug them into the formula. 6 minus 11 is negative 5. And then 1 plus 4 is 5. Negative 3 minus 11. 8 minus 11 is negative 3. 0 plus 4 is 4. For f prime, 5 minus 11 is negative 6. Negative 6 plus 4 is negative 2. And then for g, we've got 3 minus 11, which is negative 8. And then negative 5 plus 4 is negative 1. Okay, awesome. That's translations. Let's do some more. J prime, we have triangle JKL, and our formula tells us we will go 2 left, or left 2, and down 6. So look at J prime, or J. We go 2 to the left. We go down 6. 1, 2, 3, 4, 5, 6. 2 and 6. Okay, and we find our formula like that as well, right? 2, 6, 2, 6. So J prime, let's see. Negative 2 minus 2 gives us negative 4. 3 minus 6 is negative 3. 2 minus 2 is 0. 4 minus 6 is negative 2. 6 minus 2 is 4. Negative 1 minus 6 is negative 7. Alright. Now for this next two, we are just writing the rule. Okay. So I need to know how many down or left it goes, and we start from the original, which is the preimage, which is without the prime, and we go to the prime. So let's look at I. It's not around any one of them. So I'm going down 1, right 3. So down 1. Well, let's do this first actually. So right 3, down 1. So right 3 tells us x plus 3 because it's plus when it's right, and down is minus, so it's y minus 1. Okay, now let's look at t for this one, I guess. I'm going right 1, 2, 3, 4, 5, 6, 7. Okay, and then 1, 2, 3, 4, 5. So we go right 7, up 5. Alright, which tells us x plus 7, y plus 5, because both of those are for plus. Right and up, both represent plus. Alright, that is translations, guys. For rotations in lesson 9.3, where each rotation we're doing are counterclockwise rotations centered at the origin. Okay, our formula with the ones will be you will see are 90 degrees, 180 degrees, and 270 degrees. 180, 270. Okay, so the formula is for this. 90 is xy goes to negative y, x, you flip them, and you take the opposite side of the y. For 180, you just make both the coordinates negative. Alright, let me write this. Swap. And then take opposite sign of y. So the y, when we refer to y, we talk about the y from, that is the y coordinate of your pre-image point. You just take opposite sign. For 180, you take opposite sign of both coordinates. And then for 270, we swap and take opposite sign of x. Remember that x is just the x coordinate for our pre-image. Alright, so let's do some of these. So P11, we're going 90 degrees counterclockwise around the origin. So our rule is xy goes to negative yx. So I take c, which is 2, 4, and I swap them, and that take the negative value of the y coordinate. So it leaves me with 4, 2. 6, 7 is d, so d prime is negative 7, 6. And then e is 7, 3, so this is negative 3, 7. And it's plotted as follows. Remember to check your answer. You can check to see you have a right angle by whenever you take the point, plot it with the origin, and do that same, and draw a line with the origin. Do the same with the point of the image. And that is a right angle, so cool beans, we got what we wanted. Alright, so try it with all of them if you want to. Yep, right angle. And E. Okay, so then one way that was taught to me in another class is you can start, so I know I'm going to be, if I'm going a 90-degree angle, my new graph will be, since this is in the right here, we're going to rotate it, our whole graph, let's see, so where it looks like this, let's see, so, and if I do this now, we can pretend our graph is the right side up, and I can plot this like this. So just look at my coordinates of 2, 4. C would be, you can plot it D as 6, 7, and E as 7, 3. That is another way to do that, okay? Plot it that way. But if you'd rather just use the formula, just do that then, okay? Alright, so, alright, I prefer to use the formula so I don't mess up with that on accident. But you can always check yourself with the formula. Okay, quadrilateral, we're doing 180 degrees right here, which is just make the coordinates the opposite sign. Okay, so if m is negative 6, 8, m prime will just be, since negative 6 is negative, this will be positive, and then this would be, I'm going to just write the coordinates for the other one on top of it. Okay, this one is from negative 1, 4 to 1, negative 4. O is negative 2, 1 to 2, negative 1, and then negative 7, 2 to 7, negative 2. Awesome. Cool beans. That's that, guys. Alright, for 270 rotations, remember 270 is just a, also a 270 clockwise is just a 90 counterclockwise, or 270 counterclockwise is just 90 clockwise. Okay, so that way. So, and the rule for this is xy goes to y negative x, swap x and y, and then make the x the opposite sign. So, if t is negative 6, negative 2, then t prime is going to be negative 2. Positive 6, we're going to have to make that negative, or take the opposite sign. Alright, then if u is negative 3, negative 3, swap them and make the x negative, so that's why it's positive 3. V is negative 4, negative 6, make the negative 4 positive, keep the negative 6 the same, and then W, negative 7, negative 5, keep the negative 5 the same, make the negative 7 positive 7. Alright, again, 180, just make the x and y's negative, so, okay, is -7, 1. So K prime is 7, -1. Okay. L is -3, 0. So L prime is 3, 0. 0 is not positive or negative, so it's the same. M was -3, -4. So M prime will be 3, 4. And N was -7, -8. So N prime is 7, 8. Awesome. Number 15, 90 is just xy goes to -y x. Okay, this time the x, remember the y is negative this time. So if D is -7, 8, the 8 becomes negative, and so it's -8, -7. E is -2, 7. 7 becomes negative, so it's -7, -2. F is -1, 2. Becomes -2, -1. And then G is -6, 3. So the -6 stays the same, and the 3 becomes a negative, and that's what we've got right here. Applied it correctly. Yes. So, or did I plot it correctly? Ooh. I did, yeah. Yep. 90-degree angle. Quickly. It looks almost like it wants to be a reflection over the one of these lines, but it's not, because it's a rotation. So that's where that's where labeling comes in pretty important in this stuff, guys. Okay. All right. For this one, we have 270, so it's y -x. Okay, so P was 1, 3. Three stays the same. The 1 becomes -1. Q is 4, 8. It becomes -4, 8. Excuse me, becomes 8, -4. And then if R is 8, 1. This becomes -8. That stays positive, so it's 1, -8. Okay, moving on to symmetry. Alright, so for symmetry, let's check and see if it has a line. It does have line symmetry. We draw the line down the middle, and it's symmetric on both sides with that. So it has line symmetry. Alright, it's a little off-centered based on just the way I did it, so that's my apologies there, guys. I'm going to try to fix it. And that is screwed up big time. That'll work. That's good. So you can see it has line symmetry. So point symmetry we check by seeing if it rotates, if it is the same 100 after rotating 180 degrees. So I can try to do this. Let's see if it works. Rotate clockwise, rotate clockwise. Let's see where we're at. Whew. Alright, you know what we're going to do? We're going to actually go through and check if any of these have point symmetry while we're rotated right now. This one does not, because it was pointing left and down originally. Now it's pointing up and left, so no point symmetry. This one does not look the same. The point was at the top of this hexagon, this pentagon. Now it's at the bottom, so no point symmetry. This does not have any point symmetry as well. This one does have point symmetry. Okay, so this one does have point symmetry as well, because this one's pointing like down, I guess. That one's pointing up. The left is pointing down. Oh, it does not. Why did I say it did? I said it did, but I thought it did. I was confused, guys. Down and up. Down, left, up, right. And then if you go the other way, it's... No, you're right. Down, left, up, right, down, left. Okay, it does have point symmetry. I shouldn't question myself. This one has point symmetry without a doubt. Okay, so I'm going to go ahead and rotate back. Okay, so let's get back to where we were. Alright, so this one does not have point symmetry, but it does have rotational symmetry, because if I start rotating my thing, you can't see me doing this, but if I rotate it, what I gotta do is rotate it about, what is it? I don't know how, but it does rotation. If you barely turn, you start turning your paper to the left, you'll see that we can get the same exact shape. Okay, so it does have rotational symmetry, just not point symmetry. This one has no symmetry whatsoever. If you rotate your thing, the only time you're going to get the same shape is when you have done a complete 360 rotation. This one has line symmetry because of this line right here, point symmetry like we already talked about, and rotational symmetry because if something has point symmetry, it automatically has rotational symmetry. Because the point symmetry is just a type of rotational symmetry. So let me just say that again, write that up here. If for point, then you're going to check for rotational. As well. It's not the other way around, obviously, like we saw in number 18. Okay. Now, this one, there's no line symmetry. There's no lines I can draw to where it's symmetric everywhere, which is a bummer, but you know, whatever. Alright. Because you might even think, what if I do it right here? Nope. This one points up, this one points down, so they're not the same. Or points down, like on the right, where it should be, so it's not symmetric. It's not. But it does have rotational because it has point symmetry. This one has pretty much everything you could ask for. Okay, I have plenty of lines, and it's also rotational. Okay, by just doing it 90 degrees. All right. Okay, yeah, I can just say yeah. Anyway, so dilations, our last one, lesson 9.4. Remember, with this one we take. So remember our scale. K is just our scale factor. Okay, you're going to multiply K by each X and Y coordinate. That will give you your new coordinates of your image. Okay, so let's look at this. K is 2 for triangle ABC here. Then if A is -7, then -7 times 2 is -14. 1 times 2 is 2. Okay, B, -5 times 2. And then 12 is 6 times 2. This is -1 times 2. And then this is 2 times 2. That's how we get our new shape here. You plot that correctly. For this one, K is 1/3. Since it's less than 1, shape will shrink. Okay, so if J is, I know this is just a division by 3, right? Because a fraction is 1/3, you just divide the coordinate by 3. So 6 over 3 is 2, 12 over 3 is 4, 15 over 3 is 5, again 12 over 3 is 4, 15 again over 3 is 5, -3 over 3 is -1, 6 over 3 is 2, -3 divided by 3 is -1. Awesome. This gives me J prime, K prime, L prime, M prime. Alright, cool beans. Next one, 7/2. So, remember the trick I told you to when multiplying stuff like this. Of course, S prime, 0 times 7/2 is 0. Okay? So what I like to do is 7 times, okay, I'll do 2 times 7 equals 14. Then divide it by 2 equals 7. So I got that. Okay, so then for this one, let's see. 2 times 7. I don't like writing the divide symbol, sorry guys. Divide by 2 equals 7. Alright. Okay, this one. 3 times 7 equals 21. Divided by 2 is 10.5. Okay. For this one, we do 4 times 7 is 28. Divided by 2 is 14. And then 1 times 7, 7 divided by 2, 3.5. And that's what we get that, and plotted as follows right there. Again, make sure we're drawing both shapes and labeling both of them. Okay, 3/4 this time. It is less than 1, so it'll shrink. Okay, so do this. Let's multiply -12 times 3 gives me -36 divided by 4, -9. Okay, and then we have, of course, 0, because anything times 0 is 0. So let's see, -4 times 3 over 4 gives me -3. Same thing right here. They're both the same coordinate. And then also right here, because we already did that multiplication up here. And then -8 times 3 divided by 4. -8 times 3 is -24 divided by 4 gives me -6. Alright, and then this one we've got -12 times 3, which is -36 divided by 4, like we did earlier. It's -9. They're both the same. Alright. Now we're graphing the image of the quadrilateral below using a scale factor of 2/3. Okay, those are both 0, 0 because of the anything times 0. Okay. Let's see. 3 times 2 is 6. Divided by what is it? 3 will give me 2. So 6 divided by 3 is 2. Divided by 3, excuse me, okay? And then for the next one, let's see, 6 times 2 is 12, and 12 over 3 is equal to 4. So we get that one. Alright, 9 times 2 is 18. 18 divided by 3 is 6, so both of those were 9, so this is 6, 6 for E prime. For F prime, F is 15/3, so 15 times 2 is equal to 30. 30 divided 3 is 10, so we get 10 for F prime. And then last one, 3 times 2 is 6, so 6 divided by 3 is 2. That's how we get the 2 for that one, okay? We know it's a smaller figure because obviously K is equals 2/3, which is less than 1, so it's shrinking. Okay, 28. So K is 5 this time, so we're getting bigger. 1 times 5, is 5. Negative 2 times 5 is negative 10. 3 times 5 is 15. 0 times 5 is 0. 2 times 5 is 10. And negative 3 times 5 is negative 15. Alright, here we're going to find the scale factor. So I've got 2 points. I've got my points J and J prime written here, okay? So to go from negative 4 to negative 2, we divide by 2. Okay, so multiply 1/2. Okay, same here, times 1/2. Let's check the next one. Times 1/2 times 1/2. So K is just 1/2. Alright, this one is a little bit different, okay? So we have P, I did it for P, we'll do it for another point to check. P is negative 12, 12, and P prime is negative 15, 15, okay? Means we're getting bigger, slightly. So 12 times some number K is equal to 15. So what I did is set 12 times K equals 15. Divide both sides by 12. We get that K is equal to 15 over 12, which simplifies to take out the 3 from both of those, 5 over 4. Let's look at Q. Q is, let's see, 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, or negative 8, excuse me, negative 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I've already done the 12. The negative 12. Okay, so let's try the negative 8. And then Q prime is what? The x coordinate, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, negative 10. Negative 15. I'm positive 15. So, that's Q prime. This is negative 8, 12. Q prime was negative 10, 15. So let's set up the equation for the other one. Negative 8, K equals negative 10. K equals 10 over 8, which simplifies to, take out the 2 out of both of those, 5 over 4. So K is equal to 5 over 4. That's good. And guys, that is it for our video for Activity 9 review. I know I went through it quickly, but if you have any questions, of course, let me know. You need to know everything we went over today because there will be possible questions on all of this stuff. So just make sure you know the difference between everything that's going on, all the different transformations we've been doing. And with that, I'll end the video. I hope you have a good night studying, and email me with any questions. Goodbye.